Alrighty guys, this is FRQ1. Hopefully you're checking in on this. I will post FRQ2, 3, and 4 as I have time later on. But here I just made up a random FRQ number 1. Got a table and a function, and notice I've already put g of x into y1 because I am going to use that a few times here in this question. So the first part is always going to be that function composition, g of f of x, and that's going to be described by function h. So they want us to evaluate h of 5 here in this question. So for me to do that, I am going to do g of f of 5. To find f of 5, I just go to my table, and I see right here 5 is 15. So now I'm going to get that value, h of 5 is going to equal g of 15. And I'm going to evaluate that using my calculator. Since I already have it as y1, we can go ahead and quit there. Put y1, parentheses 15, and that will evaluate it for me. Remember, you always do a decimal approximation. So I would put right here, h of 5 equals negative 3.124. And it's simple as that. It'll take you just a few seconds to do part 1. Part 2 is going to be either evaluate f or inverse of f. If I'm just evaluating f right here, I'm going to do very similar to what I did in part 1. Go to the table, find 1, and that just simply equals 15. But if you're doing an inverse, you're looking for this as an output value, because remember, inverses is when you swap your input and your outputs. So I come to my table, find an output value of negative 5, and that would equal 3. If the question would have said something else, like the inverse at 0, this would be a different option. There are 2 of them. Go ahead and make sure you list both, 2 and 4. So I would write in my answer, the inverse of f at 0 is 2, and the inverse of f at 0 is also 4. This could also be done graphically, and just use the points on the graph to do this portion of the FRQ. Now moving on to part B, you're going to have 2 possibilities for part 1, a 0 question or just a basic equation. So what are the zeros of g of x? That would be my function here, 5 minus 3 ln x. We already have that in y1 because we are going to be using it multiple times in the question, so I can go right over to my graph. A standard window should work perfectly fine for this, and I could see right here that I have my 0 is about 1, 2, 3, 4, 5, somewhere between about 4 and 6. I can't really tell. So I'm going to do second calculate, go over to 0, and I'm just going to go ahead and make a window, a boundary here. Let's go from 1 to 8. And then click guess, and the graph will jump right to it. So yeah, it was between 4 and 6. It is 5.294 here. So I would just simply state x equals 5.294. If you are doing the other option for this FRQ, and they want you to figure out when g of x equals 4, you're going to have to go back to y equals and enter 4 as a second equation. The calculator will find there a point of intersection. For you to determine what that is, you again go second calculate, go over to intersect, and you're going to do curve 1, curve 2, first curve enter, yeah, there we go, got to select it, second curve enter, and then guess. Since there's only one point of intersection, it'll jump right to it, and that would be x equals 1.395 if I truncate it. So this would be x equals 1.395. And then finally, the last part will be an end behavior, as x increases or decreases without bound. Here I'm doing an increases one. So I would write my limit notation, limit as x approaches infinity, g of x equals, and you look at the graph. what's going on here on the right? We are decreasing because this is a negative logarithm graph. You could have determined that without the graphing calculator, but you can easily see it there, that this would just equal negative infinity. And FRQ1 part B is all going to be about g of x. When we go to part C, it's going to go back to f of x. That'll be your table or your graph. So one of the things they can ask you is the function invertible. So if you have a graph, you would do the horizontal line test to see if you cross more than one point. But here I have a table. So what I'm looking for here is repeat y values, 15 and 15. Or I could have also looked here and said, oh, 0 and 0. So there's actually two different set of points here that create a problem for us. We have two output values that do not have unique input values. They have two different input values that go with them. So you would simply say, no, f is not invertible. And then if you're going to explain, you would say something like the output values of f are not mapped from unique input values. That would be pretty good, but I'm going to show an example here that f of 2 equals 0 and f of 4 equals 0. Or I could have used here f of 1 equals 15 and f of 5 equals 15. You don't need to show all of them. 2 of them is sufficient. But here I'm just showing you all the possibilities. On the graph, you would do the same thing. If it's not invertible, find the 2 points that you can clearly identify and use those as your justification. And then if you're not doing an invertible question for C1 and 2, you're going to be getting a linear, quadratic, or exponential. Some of you may be able to recognize this pattern here. We're going down to a minimum and then back up, and you'll probably be able to tell this is a quadratic graph here. But the reason is because the second differences have a constant. If you calculate the first difference, and it's a constant, that would be linear. Second difference would be quadratic. Exponential would be that the output value, so here in f of x, there would be proportional. You could find a common ratio. Or if it's a logarithm, your input values right here in x, those would be proportional, so they would have a common ratio. So if you go ahead and calculate that here, that would be your justification. So I would say f is quadratic because the second difference is constant. And that should be sufficient to earn all 6 points on FRQ1. So I'm going to try to work on FRQ2 when I have more time today and get it posted as soon as I can.